just like wanted to get like between you and Cameron, you both pushed me getting a bike the most.
All right, guys. 5 minutes, so we'll get started. So usually, thank you guys for coming. I see blue faces, which is awesome. Usually, I get started by talking about things that have happened. Yeah, it's a good person. Anyways, so, oh, it's you? No. All right, so usually I can start by talking about news and stuff in React, and I usually copy this directly from React blogs, so you should just read it, because it tells you good stuff. But one of the new things is Relay was released to GitHub. You should go read it. It's nonsensical, kind of cool, but nonsensical. So go check it out. You'd like it, Tim, because you love easy stuff. It's insane. Do you not know about Relay?
No.
Awesome. So go to the React blog and look at Relay. And they also posted a bunch of videos from React Europe, which is cool. That's really all I have. So I'm just going to turn it over to Mike.
Yeah. All right.
Yeah. Mike's going to talk about a bunch of Flux stuff. So originally Reflux and possibly some Redux. All right. Yeah.
All right, yeah, so I'm Mike. I think I know most of you, but I'm Microfusion on Twitter and GitHub. Yeah, basically want to talk about React. We kind of talk about React a lot, so I'll skim through that pretty quick. I will really spend most of my time probably actually on Flux, and then RefluxJS and Redux, which are the implementations of the Flux architecture. We've talked about Flux before in here. The reason I kind of want to go through Flux one more time is because there's like what I would consider pretty important things in the Flux architecture that I think are important, that if you see the right parts of it, then that's what hopefully you'll see makes some of these frameworks better than others. For me, like, I've mentioned it, I think of like the Tucson.js thing, I'm pretty big into like functional type stuff. I won't claim that I'm very good at it, but I love the theory behind it, and I see that Flux is actually helping drive a lot of people who, like Flux and React, are helping people who basically maybe left and they're using TypeScript or like other more functional type languages are actually coming back to JavaScript. Like Dan Abramov, I can't say his name right, is like genius level, and he's doing a lot of good for the community. So anyway, I think it's kind of why this is kind of the high level. Like I want to go into some theory. In case, a lot of you probably know this stuff, but in case you haven't had exposure to functional type stuff, I want to just talk about it a little bit because it helps. Not so much on the React part, but when I start talking about Flux and the frameworks there. Then I'll share a little bit of code. I also pulled a repo down that shows a cool example. So like all the code you guys, like I didn't write any of this myself, I didn't have time. So there is code that you guys can grab and play around with. All right, so some theory. Impure functions, so there's pure and impure functions. So impure functions always return the same result given the same input, and they can cause side effects, so one or the other. So it's better with an example. So like increment here is an impure function, right? So you basically have var count equals 0, increment return count plus count. So the problem with impure functions, as you can see in this example, is if you call increment, depending on the previous state of the program, you have no idea what the result's going to be. You might get 10, you might get 1,000, who knows? Another thing that's like more subtle, but some people don't realize it, is like debug would be an impure function, like this version, because basically you're console logging to you're reading or writing to disk, right, which is a side effect. So basically, expressions made from impure functions become very hard to predict. Like I said, if the state leading up to you calling that function basically predicates what's going to happen when you run the function, then that's hard to predict what's going to happen. And that also makes them hard to test. So, I'm pretty big on TDD. I know some of you guys are. Like, basically it's going to be really hard to test those, or you have to set up the state before you actually run the function. And that basically makes the applications harder to reason about, harder to scale, and harder to refactor with confidence. So, like, I guess an example would be, imagine the increment thing that I said before, but it's, you've got a bunch of async calls, right? And each async call is going to call. Depending on the order, you don't know what the last async call is going to output. So I basically, like, the summary of all that is, if you've got impure functions, when you start making expressions based on those, it starts creating fragile applications. So pure functions basically will always evaluate the same aspect of the same method. They are stateless, and there are no side effects. So expressions that are constructed from pure functions are called pure expressions. They are considered. They're also called referentially transparent expressions. The expression which is referentially transparent can be replaced with its value and have no impact on the system. So it's better when I do an example here. It's basically, you can think of referentially transparent functions as being like black boxes. And when you have black box development, basically the implementation details no longer matter, which is why I like it. And basically, when working with a black box, the only concern are inputs and outputs. Implementation details of what's in the black box doesn't matter, which means you can replace one black box with another black box.
Hold on. Who do you guys follow? Who are your followers on Twitter? Yeah, I can just bring this button down. Yeah.
Yeah, referential transparency, like, so basically the summary of that is it simplifies the code, making it easier to reason about. It makes testing easier. It allows for more confident refactors, and it will make less fragile, more scalable code. So the example here is like super simple, but you can see how something like this could scale up other things. So multiply xy, someone wrote it in a very verbose way, but it is a pure function. You have two inputs, and given those two inputs, you're still going to get the same output every time, which then allows you to say, okay, now I can go refactor that to the correct version of multiply. It's like a black box. You can replace one function for another, and it doesn't matter. Last kind of like theory thing, the event sourcing pattern, which is basically rather than storing like the current state, like as you normally would, you store the initial state, and then you store the events that lead up to the current state. And it's better than kind of an example. So like your current state, or your initial state could be 0. You have an event that is +3. You have an event that's +1. And from that, you can basically come up with the fact that your output is now 2. It seems kind of trivial, like why would you just store 2? But the ability to store the events in between in the initial state allow you to do some really cool things, like going backwards and forwards through time, right? Like all of a sudden I want to go back, like replay my events up to event 3, right? And the output would be 3.
Before you get too far away from that, I'm having trouble with the idea that console.log is like straight from functions. So what if you have impure functions, but you do logging stuff and obvious scripts and debug and I mean, can you have a pure function with logging inside of it, and then like would you like turn that off in production or something?
So like I was kind of telling Chris this example, like so I've been trying to learn Haskell. Like if you read like learning Haskell. They don't talk about Haskell tries to be like very explicit. In JavaScript, I mean, like, so that's where you can say functions. Like my code, I would not like. I mean, I guess how you would write that in a pure way is you would probably return some structure that has like the output string as something, and then you would let some other impure function do the writing space.
So kind of like middleware or something, like somewhere down the line.
Somewhere down the line, so you have like all your like core business logic that's doing things, and then you can have, as long as you return like the messages that you want out, then as long as they do the same thing, you can still have pure functions that are returning like an object with a message and a result, and then at the end, somewhere down the line, that. But again, it's like there's kind of that balance. Like it's kind of like the same thing with like baked-in, right? Like I was spending a lot of time trying to do baked-in JS stuff, and sometimes it becomes really hard to stay in that like pure perspective.
Sorry, but the idea would kind of like write the functions and let the consumer decide who they want to log or not.
That's kind
Because
of
it's like if we get a module from NPM and it just starts logging, we're like, I didn't ask you to log.
Yeah.
So it's kind of that idea. Of like,
yeah, that's exactly right. Yeah, if it's returned versus like actually does something to the state.
because then it's doing like two things.
Yeah.
So the function should try to do one thing. Right?
Yeah.
Okay.
So that's kind of like, again, like there's usually a balance between functional and.
I got some of that.
Uh-huh.
It's not really bad if it's not pure either. It's a mathematical function. So the typical functional way do something like logic, you could actually create a function, query function blocks. And then when you want to do multiply, you basically do call and log and pass your multiply function and then arguments into it. And then what that lets you do is like if you want to do some testing, you don't care about the logging, sometimes logging you get into the testing. This is where the UQ effects testing happens. So
That makes sense.
Yeah, that's like currying is like that's a really good example of like where you can kind of like wrap the helper functions on top of it. Yeah, that's a good. Is there anything else before I move? Because I think I'm done with theory. Is there any like other things?
You're going to tie those two theories into something practical.
I will. So the event sourcing will be.
Just, yes, good.
Yep.
I'll wait for it. I'll wait for it.
I will actually show a
No
demo of
spoilers.
event sourcing. Okay, so let's see. So a JavaScript library. Okay, so React. I'm going to go pretty quick through these because we've all talked about React. But it's basically only the view component, and it's technology stack agnostic, which is pretty cool. It's basically, the reason it's good is basically because it's simple and declarative. It's about building reusable components, which kind of go back to your question, the reusable components in a way become similar to this like black box type methodology, right? Like all of a sudden you've got these components and they're not going to affect other components, and you just kind of put the data in and they do what they're supposed to do. I guess that's why I said it there. Let's see. Basically, in order to stay encapsulated, React does use some unfamiliar conventions, some of which we've talked about in here. It doesn't use templates. We've talked about that. Mostly it's JSX, so you can do it without it, but the syntax becomes a lot uglier. But I guess the key is that, again, it like makes us a component that is kind of a standalone thing. But then if all of a sudden you want to replace it with something else, it's not, spaghetti code to try to rip it apart. So there's an example of a React component. Okay, so what is Flux? Flux is the application architecture that Facebook uses to build client-side web apps. Flux basically complements the composable view components by utilizing a unidirectional data flow. And it takes a more functional approach of how data is handled in web applications. It's a pattern, not a framework, which is kind of why I have to talk about both Flux and then I have to talk about Redux and the other frameworks. There is no requirement to use Flux architecture when using React. And I want to go back to, just real quick before I show the next slide, the unidirectional data flow. So that's the one that where I kind of fell in love with this over, I've done a long time of Angular stuff, and there is not a unidirectional data flow in that. You have your scopes and you've got data going back and forth, and depending on how many components are listening to the scopes, it can get kind of confusing. And if you watch the like Facebook React, why React type of thing, they actually go into that. They make a statement as far as saying that they think MVC doesn't scale. I don't know that I agree with that, but like I think it gets a lot more, like you have to be a lot more careful about what you're doing as you start adding to it, because I've seen it firsthand, like with Angular stuff, that it starts getting. Let's see. ReactJS and ReactJS and Redux. So they're both implementations of the architecture. Reflux, actually both of them strive to be more functional reactive. Redux is completely decoupled from React. It has live code editing combined with a time-traveling debugger. So that's where I'll get to the event sourcing stuff. This pitch was originally just Reflux, and I wrote it as that. and then watch Redux, which you should watch. There's like a creator dance. That's it. Basically shows him doing some live coding in it, and it's pretty amazing. And then one of my buddies, you guys know him, Jason, went off and spiked on it for a month, and I'm completely sold on it. I think they both have their pros and cons, so I would like go for either of them because they're in that functional. They do it the right way, but there's small nuances between the two.
How fast things are moving.
Yeah, you gotta
Just
stay
1
up
month.
with it.
Yeah.
Don't fall asleep. You're gonna miss out here.
It should be the time. This is a good time to know that. What do you guys know the Flux implementation that just gave up? They like posted on GitHub. They said we're done. You should just use Redux.
Oh, did they really?
Yeah, I forget. It was like it was Flummox. I think Flummox. Yeah, they just.
I mean, with a name like that.
Yeah.
I think the Flummox guy actually became a contributor, like a core contributor
To Redux.
Redux.
Yeah.
I've seen that guy. Like he seems like.
But that's what stage we're in with Flux. It's like
Yeah.
we're in the funnel stage where it's kind of
I think it's like I would place money on Redux, but I don't know. I like them both. So, so here's like Flux as Facebook says. So again, like if this was MVC or something, you would have arrows going both ways between some of these, which is what makes this so powerful. So you got your action, you got your dispatcher, you got your store. I'll go into the details, but an action is just basically like your normal event in action. Dispatcher helps connect actions to like basically to the stores, and then your stores are similar to they're not models, but they're basically going to be a collection of models. And then your view is everybody knows the view, and then you got your user. And because it's unidirectional, the user will hit back on the view, and it'll go back to an action, and it'll go inside it. The stores contain application state and logic for a domain within the application. Again, it's like a collection of models. And then views basically listen for changes from the stores and re-render themselves as needed. If you're using React, the view is your React. I think something that like I got hung up on when I was going through stuff is I don't know. I thought it was like something that probably shouldn't have been in the architecture because you could probably accomplish the same things without it. And luckily, other frameworks felt the same way because basically there's no business logic in it, and it's mostly the same depending on the different applications, or you could do it slightly differently. So it could be argued as an implementation. So RefluxJS and actually Redux both remove the dispatcher completely from the flow. They push the responsibility, like at least in Reflux, they push the responsibility into the actions. Makes a lot of sense.
Cool.
So that's one thing you're going to get with Reflux. Yep.
Aren't there some Flux notations that like the dispatcher's job is to put things in a queue and do them smartly, right? Like if it can call an action inside of like a RAF loop or something, so it if this like to make sure to do things in a performant way, then it's like the single source of being able to optimize that, right?
Yeah, that's probably like I don't know, like I haven't studied the dispatcher that much because I didn't agree with it in the first place. But
Yeah.
I would say like a lot of these, like with React, I see a lot of times where people are like maybe prematurely optimizing. Like even in the Redux stuff, like there was some stuff where they were blocking rendering of like child components, and it's like really like with the virtual DOM and stuff, how much MIPS from the browser are you really saving, and is it worth all the complexity? So I would almost say the same thing with the dispatcher, and I think a lot of these, because they push them into the actions, they're almost like one-to-one. Like when you fire it off, it's actually going straight to the action, which is then kind of doing its thing.
Just to be clear, the dispatcher, is that like the event handler?
Essentially, yeah. That's so the way I understand it is like it's just like an array of callbacks, right? And like you basically attach all your handlers and listeners and then like basic processes.
The actions and events and the storage are like the.
It's a registry, right? It's just a registry for callbacks.
Yeah,
So
yeah.
if I play this back real quick, so I'm looking at the action. The action controls all the things going on, right? And the store is kind of like the model. And then you got the view. So it's kind of like M, B, and C. These three boxes.
You can, if you go on Reddit, there is people who like will take Flux and MVC, they'll take the pictures and they'll rearrange them, and it'll be like pretty close to the same. So I will not argue. Like that's kind of where I would say at the beginning, like they make the statement that like MVC doesn't scale, but I think like if done right, MVC can get kind of close to this. Like the difference is like this forces you to like, I guess like the data binding and stuff like that, right? That you would do in like Angular per se, like where you've got.
That was an Angular thing. That was really MVC.
But a lot of the framework, I think this is like one of the few frameworks that doesn't have like that data binding in the browser, like where when you do stuff, it doesn't go change the model directly, right? Versus like here, it's like when you do stuff, you can't change the model. You have to go fire an event, which makes it's basically you're forced to go through the event loop instead of like going right back to the controller or the model to touch stuff.
It's a separation of the model from the view along that. Each of these are very and so you don't create a store for a view. You create a store for different data domains in your application, and your various views subscribe to those stores. Parts of model the views.
The actions are just literal things, right?
Yeah, the actions are just
Nothing else.
like an object, right? Like it's like a string and like a type or something like that. And going back to what you say, yeah, that's exactly right. And that like even Redux, when we get to that, they've said basically we'll only have one store for the entire application. So all of your application state is in one store, which I also really like because you can look at the tree and see your entire application in one spot.
More things change than those things.
Well, yeah, look.
Very kindness is 40 years old.
And that's a lot of this, like.
It's a pattern.
Yeah, these patterns are like a lot of them aren't new, right? Like we were talking about event busing, right? Like that stuff's like not brand new. But what I like is that it's kind of making its way into the mainstream frameworks finally. And I see the more and more that like the old school framework like patterns are starting to come into the client side. The more we're getting like good people that are like starting to jump on top of that, and then you start getting like really cool architectures that are built out of it. And actually, if you look at one last thought on that, if you look at the Facebook presentation, they'll actually say they're trying to do it like the 90s, because basically like before you would do all your stuff server side to be like the full MVC loop, and then you present your page, right? You didn't have this like separation of client side and server side, and so they're basically just trying to like replicate what you would do all on the server, all on the client. They explain it better than me, but.
I was there in the 90s, so that's why I'm saying it's sticking like that.
Yeah.
Well, the big difference between the model that React has and the model that like Angular has is that Angular by doing something in the browser, you can change the view.
Mm-hmm.
You don't change the model. And so in React, you have to change the view, you have to change the model. Right?
Yeah, exactly. Yeah, because it is that one
and
way.
So it's basically linking the fact that if you want something to display a certain way, you have to change the model to have it display that way. So you're basically forcing this event loop through, so you don't get into this state where I clicked on this thing and then I clicked on this thing. Well, what the hell does it look like now?
But you're going around in a circle instead of going back and
Yeah.
But again, that wasn't necessarily an anti-MVC thing. That was Angular saying, hey, this is cool. And everybody said, this is awesome. And now they're like, this is not awesome.
Well, and it's interesting too, because like kind of like you were saying, there's like the flow, but it's also like you can look at it the other way too. Like it's more of the reactive flow where like the view is actually listening to changes in the store is listening to changes from the actions. So it's almost like the arrows could go the other way, but it's like one thing changes and it propagates all the way up because everybody's kind of looking downward. Anyway,
That's straight up MVC.
Is what?
That's straight up MVC. The view reflects what the model is, the controller changes the model. So here we're saying the view is going in the same, instead of updating the view that then changes the model, but then the controller says, oh, what the F just happened? I need to go send it back to the server. Instead, we're saying, no, it doesn't go backwards. It just goes back to the controller. It's, hey, controller, I want to change on the view you just clicked on. I want to change this thing.
So but the difference is that when the model changes, it actually will go, do I actually have to update the view from the model change, right?
Yeah.
Do you have actually this smart kind of thing, so I don't actually have to re-render.
Sure. But again, that's up MVC will do the same thing. It's not going to update a table because the data model has changed and affect the table.
There is like a nuanced difference, which is kind of like pretty important, at least from my mind. Like, because even it's not just like an Angular thing. Like, look at any like MVC architecture, like even Rails, right? It's like you can take the Rails pattern, and it's like you got your models, you got your controllers, you got your views, and then usually the views go back to the controllers, right? And then they will update the model. So it is like it's that unidirectional versus like forcing it to go all the way back to like an action that propagates this way through like from the data changing. It's basically like another way to think of it is like data driven, right? Like when the data changes, then the rest percolates up versus like kind of down and back up. I like the way you said it better. Let's see. So it'll help maybe when we have some more examples. Let's see. Redux. Oh, so this is why I mentioned it again. So Redux does go to like a single store for the whole state of the application, and then you basically use reducers to get the specific part of the view you want. And I'll talk about a reducer in 2 seconds. And it uses the event sourcing pattern, so this is kind of why I brought this up. Basically, so your initial state is going to be your single store, and then you will use reducers to transform that store into your current state. I'll show you. So the reducer is basically a pure function. So what you're going to do is you're going to get the previous state and an action, and then it's going to result in the new state. So actions will basically come into a reducer along with the previous state, and then based on that, you can switch on the action and then return a new state. And that's kind of the pattern. So it's almost equivalent to the reflex flow, except you've got a reducer in the middle there that's going to take both the action and the store and create a new data that goes to the view.
What's the significance of the second era?
So this guy is really coming from the action, and this guy's coming from the store, and that makes a new data set that would be coming into the view. Okay, any questions? If not, I've got like little snippets of code that I can show that might help clarify some of it. So here's the 2D MVC and Reflex. So the one thing about Reflex, it's got a lot of helper methods, like they basically keep the code dry. So to create an action, this is basically what you do. You have to-do actions, you create a bunch of actions, and it's going to do magic now to bind that to like your stores. So on here, so here we have edit item down at the bottom. Over here, we've got on edit item. So basically, because we've said you've got the mix in of to-do actions now, which is the listenable. Now, whenever that action's called, it's going to automatically call on edit item, and it's going to pass in the key and the label, and then you can do stuff like that. And then here is where you're going to trigger, and when you trigger, that's going to notify the component that I need to re-render myself, or that I've got new data.
So the on edit item, that just takes the name from the action?
Yeah, it takes the name from the action and adds an on to the beginning. But basically, so I think there's ways to do it without having the magic. But they basically added a lot of magic to make it pretty simple.
That's reflex specific.
This is
Right.
reflex specific, yeah.
So, and that's actually taking place. Sorry, that's taking place in the dispatch. They got rid of that, right?
Yeah, so basically, yeah, the magic they've created here.
Because they've added a listener on the store, these actions that happen.
Yeah, they've created, they've gotten rid of the dispatch right now. And then you got your component, you see there. So this last one, we created the, basically this is a to-do list store. And then over here, you've got your mix-in, where you're connecting to the to-do list store, and you're saying, basically, listen to the to-do list store, and then put it on the state list. And then you'll see down here, we've got the state list, which will be automatically like filled in with all the data that you triggered. So that's kind of like, I mean, it's pretty simple, like conceptually. It gets harder when you start doing like complex stuff.
They have an ES6 like answer for the mix-in. Is there a way to connect to the stores without you do like a higher order component thing?
Oh, without doing
without mix-ins, yeah.
I haven't seen. I mean, they seem like they're more like the mix-in flow, and then Redux is very ES6 heavy, like from all the code I've seen.
Right.
So they do it a little bit differently. So yeah, I haven't seen it, but it might be.
Yeah, it seems like a lot of these like magic mix-ins, they just replace them with higher order components.
Yeah, little decorators.
Yeah, the decorators.
And then here's again, all this code's like on my GitHub, so if you guys want to like, take a look and grab these links out. This is in Redux, and it's kind of similar. You've got they're a little more explicit. Like they don't help out as much with like some of the helper methods and stuff, but they're better in other areas. Like I said, like you don't have to use React with these. Like you can, there's an Angular plugin, so if you want to use Angular as the binding front end view. Let's see. So there's this, and then you got reducers, and so. Here's kind of the example, like you've got your state that's going to come in, you default it to the initial state, and you've got action, so an action would be one of these guys back here. And then, for example, then you would switch on the action type, let's say it's add to do, and then you're going to return the new state. So again, it's a pure function so that, basically so that you can do all the expression stuff where you have like your initial state and then you build up the new state from basically this list of actions that comes in. And then here's nothing really, except for comes in on props instead of state. Questions? Oh, before I do the questions, let me just show you real quick why, let's see. So like here's the Redux, here's some of the tools that they provide, and they have different versions of these, but because they store state and everything's like pure function wise, like so you can like, you add a bunch of stuff, but because they keep track of the history of how you got there, you can basically like travel backwards and forwards through time, and you can like replay it. And like if you tried to do that in like a stateful, like something that wasn't like pure functions, that would be very difficult to do. And if you watch the talk, like again, I don't know, it's like way better.
So it doesn't record the whole state; it only records the change, right?
It records the actions.
Or the action.
Yeah, so there's basically like your state and then like a list of actions, and then that's how you get to any one of these like intermediate states or the current state. That's pretty much it.
But it will technically, that's with the dev tools enabled, that's like we talked about, it's like a memory leak. It will just continue to store forever.
Yeah,
it's a purposeful memory leak where it just...
I've heard, I think Jason was saying yesterday that they're trying to fix that, like by putting like a, I guess you'd have a queue and you flush stuff off the back or something, I don't know.
Right.
Instead of sliding window.
Because with
yeah.
one store, if you have a semi-complex app, one store, it's going to be huge, right? I mean,
yeah, it could get pretty beefy. I mean, like the tools, like this is more in my mind, like I don't know that I would use them that much, other than like they're really cool at showing like the potential for why this kind of basically your composing stuff. It's just, it seems a lot cleaner. Like you could never, like it'd be really hard to do this with Angular, and I think that also shows the complexity of Angular.
Do these give like a way to modify that global state? Like, can you just go up and change the store state to like, so if you were testing like a modal, you could just go into the store and go modal open, and then it's open, and then you can, you know what I mean? Like, it's easy to.
I mean, you kind of could, because right here, you would have like, jumping to here. Now you're all the events or all the actions at timeline 1 or whatever. But if those events, if you treated everything very pure function-ish, modal would be one of those things like open and close that would come from the store.
Right.
So if that's a value in the store, then it would propagate up, and then
you just toggle between the state open, close, open, close.
Yeah. And I think some of the other tools, like this was the one that looked kind of coolest, and I like downloaded it like an hour ago. But like there's other ones where I think you can actually like interact with them a little bit more.
Redux, you pass the entire state into the store on each action call. Right. So you can actually create a mock file with, like JSON data or whatever for your app state.
Right.
And you can pump that right into the store and test with it. So if you know your expected input and expected output, the store is a pure function.
Yeah.
You can actually do pretty easy unit testing on a variety of different components, both in the store and in the user interface.
Yeah. Yeah, and I guess if your state is always going to be serializable, right? I mean, they're going to have functions in your state, right?
You can, because it's JavaScript.
Right, but like it wouldn't be good to have a function in your state. Like that'd be weird. Because it'd be cool if you could like on an error you could serialize the whole state and save it off, and then you could have your QA team just put that state in and be like, yep.
Well, just back to your hybrid stuff that you tried to do, and was it lend itself more to that as well? You could send out an app that's hybrids and started in a spot.
Yeah.
So this would be good for customers too. If you could enable like a sort of capture state when they're in a really weird place with your product. Yeah, totally. Yeah, I think that's like what's pretty cool about it is all this is I don't know when Redux came about, but it was not nearly like it's probably been like exploded over the last like 2 months. So it's kind of like the architecture foundation's there, and now there's going to be a lot of cool tools that will like be built on top of this. Like this isn't actually part of Redux. This is a tool that somebody built basically to show, that you can go back and forth in time with it.
And any of the Flux frameworks offer that ability to kind of eject your apps. Like the Facebook implementation of the dispatcher, you can do it. You can have a little button or a keyboard hotkey that, since the stores are subscribing to the actions, then you could just click this key, and every store will just basically ship out however you want it, the application state. You can then, use that to recreate the.
Yeah, that's kind of the power of like the data-driven type architecture, where if you have a snapshot of the data, you should be able to recreate all the views and stuff fairly easily. Versus like anything else, is you have to basically replicate all the steps that got you from the initial data to that view state.
Back to the stores in Redux, you said that Redux is a single unified store.
Mm-hmm.
So I don't know if it showed that, because it's to-do apps, I was really sure they only has one store.
Yeah.
One domain object in it. So how does that work if you got more than one domain object? How do they build?
Yeah, so basically you can listen to in your component, at least the way we were doing it, is you can listen in your component to a subset of the store. This is essentially how you do it. So like the store, because you have a global store, you have basically a tree that's going to be all your child components. And so you could listen to one of those specific child components. So even though you've got one store that's, and I think the way they actually Redux recommends it is I think you're supposed to like pass it down via prop types and all that stuff. But the way we're doing it is slightly breaking that, but it's same conceptually. But I guess essentially the way we're doing it is each we use a decorator on the component that basically just listens to the one portion of the tree.
So it's wired into one store, but you're basically going to filter it so I only listen to this part of the changes.
Yeah, and I think that's basically what you would do, like with the true way of how I think the code, when you pass it down to prop types, is basically what you're doing. You're saying like you take the subset of the tree and use it for your stuff.
That's very like
it's
a very like
to do items, and you had a list of current users, and the two item table saying, I just want to see this stuff, so it changes here, I'll re-render, do my thing, there's stuff here. It's at the component to actually deal with what it wants to listen for, change orders.
It would be more at the where you're setting up the component. So the component doesn't really know what it's listening to, but you would say the component expects these props to come in, and then it would be wherever you set up the props to that component, I believe.
So your store can live at the top of your UI hierarchy, and it's getting the updates whenever the store data changes, and it trickles down the data through the props to the lower components. So the lower components don't even know you're using Flux at all. We can have multiple stores at the top.
But where are the components? It sounded like you're saying that the components are actually registered listening for a specific piece of the store part of the tree. Is that not quite accurate?
That's how people use it. They create a separate store for each section.
And then I'm saying here it's the one store. So how's the component?
It doesn't really listen, right?
It's not so much listening as it is getting like the for example, like
so you're talking about like the reducers, and the reducers were saying, I know which piece I'm going to send on down and rerun the components.
Right. In this
If your app state had users and to-do items, that's sitting at the top of your application. That passes down to-do item. It'll pass down state.to-do items to to-do items component, and it'll pass down users to your users component.
That's the question. That's it.
Well, in their implementation, in a traditional, you would actually just select that at the top level component, and the to-do component would get state.todos. The to-do, like the completed list would get, something else, or you know what I mean. So you'd pass them down via props. What they do is something slightly different, where the component says, I want state.todos, and then the store filters them and says, okay, it composes that.
It does come back to the actual component registering what it wants to listen for.
Kind of.
I'm not sure.
Either way, they're kind of the same. Like, so in the way we did it, which is, again, like I would almost rather go back to the way we were passing it via prop types, because it's kind of verbose, I think, which is why a lot of people don't like it. But either way, like with the decorator method that we have, it's like you have your component, and then you're decorating the component with, I want these things, but the component still doesn't really know what it's subscribed to. It just knows I'm going to get some props that are this thing, and then I'm going to act off those props. So it's never doing, like, again, like that's that unidirectional flow, like it's never fetching outward.
Well, I get that. It's registering a listener, saying I want to listen for these types of changes. Right?
Essentially, and that's kind of what like the props are to begin with, is like, so like when you set up your hierarchy of components, you would say like, here's your top level component, the top level component would pass in like a subset of its components, whatever's needed to render this component. Okay. And then it would get the props and then do things based off that.
But there's no actual event listeners.
Yeah, it's more, again, like it's kind of that reactive, like I've now got this, I'm going to go render myself, I guess.
Well, that's part of the actual React cycle.
Mm-hmm.
Right? Just talking about, hey, go render yourself. Go do your thing.
Yeah.
Because we're talking about here about the data flow. What data is going to be getting, so then you can render itself.
Yeah.
And the reducers, it sounds like in Redux, are the ones that are figuring out, hey, I'm the current user list for the to-do app, that changed, so therefore I'm going to take that piece of data and give it to this user list table, so that here we want to see it's usable. And the to-do list changed, and therefore I'll get that piece. So
yeah.
Well, it's more of a calculation too. It's not just I want to listen for this data. You're actually in the reducer.
Yeah.
You're actually saying I want to take these two pieces of data and only give it this.
Yeah, I've got this action and this value.
Yeah. So you're not just mapping. You're actually doing the reduce. Right?
Mm-hmm. Yeah, exactly.
Well, and then you're not modifying the state. You're just copying it onto the state.
You're creating a new state.
You're in a new state.
Yeah. Sorry, back on the code. Do you actually have an example of reducer that was non-trivial?
Does Redux have one?
Yeah, there was one that showed it pretty well. I mean, in your example.
Yeah, I mean that's.
I
mean, the thing that makes them,
There you go.
no matter what, it's always pretty trivial because they're like pretty simple, right? Like your reducer is basically just going to take your initial value in an action and return a new value. the new values then again get set to the prop type of whatever component is basically hooked up to it.
Okay.
Isn't the delete to do a big no-no? Shouldn't you? I guess I don't really know how to delete stuff in a nice, like, immutable way, right? Like I guess filter does return a new.
Yeah, it's returning a new. If it was actually like modifying,
Yeah, so it's
the
not
state,
splicing it or something. It's
Yeah.
actually, yeah.
Yeah, I think that's the difference. By
Yeah.
returning a new state, you're okay.
Yeah, in case you guys don't know about ES6, that's what that state is that's basically, it's kind of hard to understand, but it's like taking that array and you're changing the state of this one object and you're passing that in, and then you're spreading the rest of the values of state into the array. So that's
So all the
things that are
not
different.
ID completed,
Right.
accrued
So
pending.
that's for the ad.
Yeah, for the ad.
There, it's actually yanking a piece out
Yeah.
and back and brand new.
Or brand new
So-
array.
Yeah, it's
Where
sort of like
does the initial state have any? Oh, I see. The state is the state. Okay.
so yeah. Again, like this is like an ES6 thing, but like it's just basically default whatever your default
Yeah.
state would be for your tree.
And this is for everything.
Yeah.
It states literally everything there is.
Your entire app.
Yeah.
So it gets really complex when you start having a lot of actions.
Well, I think you
Bigger switch statements, more functions.
Oh, yeah.
Yeah. Yeah, I mean, you could probably like divvy it off to helper files and stuff like that, I would imagine. But there's also, I read something where someone was complaining about actually using switch statements, and basically the author basically said like switch statements make it very easy to get the concept, and then like you can implement it however you want, basically.
Well, I've seen you guys do this, right, you can just split your reducers into multiple reducers, and your switch statement can become very small. You're like, here I'm only going to listen for these types of actions, and this one I'm going to listen for these types of actions, and then you just combine them, and then it will just merge them together into one big array of reducers, and then call them.
Yeah.
You could technically put them all in one gigantic reducer, but that would be terrible.
Yeah, you can compose reducers, I think.
Yeah,
basically.
right. So there's Redux has like a compose reducers thing. Literally, that's what it's called.
Yeah.
That you can give it an array of, reducers and it mushes them together, which is obviously necessary for.
that kind of syntax.
No, it is. You can put them all in one, and then kill yourself.
Some
Do all this shit.
Yeah.
Multiple files.
Right.
It helps though, like if you can isolate your reducers by domain or whatever. Right?
Yeah.
And you've got like, I don't need to go look through a 1,000-line file to go look at like something that only affects APIs or something like that.
And you're going back again. So these reducers, how do these tie back into the source? How are these connected to those?
I don't know. I didn't actually show the example. There's some.
Probably in the main JS file, whatever that is.
You see the main?
No.
I don't know if it's. Yeah, you think it's in here?
I guess it could be.
I mean, one place.
It's the weirdest code I've ever seen. Why are they using the exposing module pattern in 2015? That's dead.
I was gonna see if they have it in here. Oh yeah. See, I haven't looked at this code enough. I have other code that's like, and go do it out. But basically, there's a place where you basically just say connect, like you're connecting your reducer to your. There's like it's like 2 lines.
Okay.
So it's pretty trivial.
You just say like store reducers.
So there's no magic. It's a.
No, yeah,
it's
you're
an
doing
explicit
an explicit connection. Yeah.
Cool.
And then that's where. What? Say it again.
The components file
Oh, is it in there?
should be at the top.
This makes sense. Wait, what? Oh, I'm looking at reflex this way. That's a good problem.
There we go.
Let's see. So this guy. JS.
No, it's probably in certain client.js, or is it like a, or in server.js actually?
Server's going to be
Okay, that's your dev server.
index.
guess maybe it's an app, maybe?
Yeah.
Container app, yeah.
Oh, okay. Yeah, yeah.
There it is.
There it is. So yeah, here's where you compose your stuff. Reducer, combine reducers, and then you take your reducer and you create your final store from it.
And you can see that they've chained some different stores together, like the persistent state store. If you took that one out of that list, you probably would just, your history would be gone. And that's how awesome the composability is.
Yeah.
With Redux, it does it through the pure stateless store model with Facebook's Flux implementation. It does it through the dispatcher.
So that provider component's kind of important, right? So that's brought in from so you said React, Redux is split out from React. So React is they split off the React implementation to a different library.
Yeah. Oh yeah, it's very important. Yeah, so like you say, the provider, instead of React Redux, there's an Angular Redux that you could put in its place.
Or React Native, right?
Yeah, whatever implementation you want. But yeah, that's basically where you do the glue for that. So this file, yeah, is pretty important. I probably should put this in the presentation. This is where all the glue happens.
So isn't having a dynamic object or array, it's the global state, and filtering it, it's a very functional thing, like a Hadoop type thing where you just funnel events and then you're going to map and reduce them into some other output. It's very...
Yeah, as far as I know, I mean, it feels very functional to me, but...
Right.
And again, you were saying, with the compose, this is the time travel example demo. So you can see that you could remove dev tools and persistent state and probably just create the store, and then all of a sudden you've got just a normal production version or some form of that.
Awesome.
Any other questions? Yep.
Questions? Kind of a broad question. License as well. So these stated here, modeling data, but do you ever use this single state to also represent UI state? For example, you want components to react to changes in window size, or maybe having menus that pop up, which that sort of thing. Is that something you also represent this state on?
I think you could. One thing that we've been playing around a lot with is the dialogues, right? And like Charlie was saying, right? Do I want to pop open a dialogue or not? And I think state might be a good, there's props in their state, but having it come through there might be good. But then also, a lot of these examples are your to-do MVC where you don't have the server running, and so there is complexity that gets added when all of a sudden you're doing GET requests to a REST server, and it could maybe get confusing. I guess I'm thinking through it. I don't know the answer for sure. I don't know. Do you have thoughts on it?
The good question to ask about that is, do you want the user to be able to reload the page and get back to the same view? If having the mouse hover a menu and open isn't important across navigation, there's no reason to put it in the store. Just store it in your
CSS.
Use CSS or use React state or whatever thing you're using. Just go with it. But if you want to be able to recreate that, or if that's important for you to describe the application state, then throw it in the store.
I guess started thinking of this really idealistically when I first learned about it. It's it would be nice to be able to restore any state for troubleshooting purposes, but what you pay for that is probably whatever you want to pay for that is probably your question.
And kind of depending on how much your view state derives from your data, right? If your data says I'm in an initializing state or I'm in a something state, then if you've got an object that comes back in an initializing or pending state, maybe you'll show a spinner, and then when it's in a ready state, then it'll show the actual state. So those things I think would be important because those might actually be something that comes from the database. But yeah, maybe the dialog box is something that you don't care about if you refresh your browser.
I was just gonna say, I don't know if it's a crazy idea or not, but you did track the state, like everything that's happening, you could have A/B testing to see like 10%. Like how do people go about using your app
Yeah.
and everything? Just kind of get some insight into, I don't know, just seeing like how the app is being used.
Yeah, that actually might be kind of cool.
So have you guys done ever implemented any, like, so for example, like say you have your page for some reason still needs to react via JavaScript to like window size, right? Like, would that be appropriate to go into an action? Like you have a reducer or an action that the action, what it does is when it gets called, it just listens, it sets up an event to listen for window.resize. And then when that happens, it can dispatch some new state saying window is now mobile size, window is now tablet size. Like, is that, have you guys done anything like that?
I haven't. I'm trying to think through what I would do.
Is it a
You
pro?
can use media queries and it's like, here's a new class name.
Well, say you want to use like match media, you know what I mean? And you like, you know, listen for window resize and then use match media in Java. Like for some reason, there's something you have to do in JavaScript. Like, it seems like
people have done routing off of basically the actions and state. So all basically your path name is just another piece of state, and someone pays attention to it and redirects from there, which is kind of cool. So it's the same type of thing where you can store whatever you want. Doesn't mean
Right.
you should store everything.
right.
So somewhere in there is kind of like that.
Yeah, I just wonder if it'd be appropriate to put like a window.resize or, you know,
If multiple things are to respond to it.
Yeah, that's the thing that I'm almost, there's part of me that says like that specifically might be like overkill to have all these events come in just for like, but maybe not. I don't know.
Because window.resize,
fires a lot.
you know,
Well, if you don't throttle it, let's say you
Don't
throttle it
throttle,
and you
yeah.
debounce it, then you fire an action that says this, you know, it's now on mobile size, and you could propagate those style changes down throughout the app. Like,
It kind of goes back to whether or not you need to save that, because
right.
you're not throwing out all of the existing JavaScript. You're going to have in your UI components some kind of event that's negative resize.
Right. The resize, right.
And that's going to scrunch down. If you have data that has to change, then you can call the store from within that event handler
Right.
and update the data. But if all you're doing is rearranging the layout of the page of JavaScript, just do that. Nothing in the data is actually changing.
Yeah. So you think it's probably especially to keep the storage related to the data.
To the data or the apps, maybe a good, a more reasonable use case for doing something like that is you've got a big one-page application and you want to make sure when somebody navigates back to where they came from 2 pages ago, the scroll position is saved.
Yeah.
Or if they reload the website, that it goes to the same scroll position. That's something that React doesn't handle on its own. You're going to need to save that somehow. But
Right.
usually that's still kind of overkill. You don't really care about that kind of stuff. It's self-contained in the session. It doesn't need you don't ship back the size of your window to your database.
Right.
but you could.
Yeah.
What concerns me about kind of it seems like if you don't put it all in the state, then you're asking people to think. And I try to think about like when I sell this to my teammates, like think in 2 different modes. Like you have this sort of evil thing you're doing with UI, unless you're dependent on the data. It's like it seems like you might have to. I haven't actually worked this out, so maybe it's true, but it seems like you have to have kind of 2 different modes of thinking. Like one that actually still like is listening to the DOM versus kind of the state of the application.
So components still do have state in React. Like you've got your props that come in that kind of like
So
do
props
things.
always
Well, there's props and then there's state, and state would be like component specific state. Like I'm gonna get stuff fed into me, and then I'm gonna do things, but maybe I want to keep track of it for when the next time a new prop comes in. That would be like a state type thing.
Don't say move up and down too.
I think maybe I just think about
might.
this too extreme of a way.
Well, state will only move down if that state at the top level passes props down to the child component, right?
Okay.
That's the progress that you find is a good thing in React state.
Yeah.
Self-contained component, self-contained in the session. So it doesn't impact the rest of the app.
Yeah, I think if you keep React components like a black box, I guess now I'm working this out in my head. then it would make sense for the component itself to handle things like the size of the window, because it should know how to render itself outside of Flux. It should know how to render itself in a small window or a big window, or whatever.
Yeah, and
so that's where its internal state is what's important about, like.
Because like we use Material UI like as like Material UI and Reflux Reflux together.
You're watching Netflix.
and I was thinking through that scenario, and I'm like, I've never, because I've relied on Material UI, I've never had to worry about like the window sizing and stuff.
Yeah.
But it's been completely responsive,
right.
Which means that those components are addressing all that stuff themselves.
Right.
So I think that's the right way to do it.
That makes sense.
All right, what are we gonna watch on Netflix?
Ideal husband.
Ideal husband. Let's do that one.
Give me this.
Any other questions? I would definitely I'm basically like regurgitating stuff from the internet, so there's lots of good stuff out there.
How would you go about unit testing on these Flux implementations?
Unit testing is not easy. Like, at least I don't. I mean, maybe you guys have opinions, but like I haven't done any in So I take that back. So unit testing should be a lot easier because you're state driven, like you're data driven. So like you should just be able to give it a component. But rendering hierarchies of components, I've had trouble with, like especially when you start adding the router and stuff like that. I played around. Like the furthest I got was basically I played around with. Was it we only go one level deep?
Shallow rendering.
The shallow rendering, and that gave me the most.
I started looking at that. Yeah, but that's really for like components. I could just see where it's been made.
You just want to test. Yeah, you just want to test basically the components. But that's like kind of where we're at, where I'm starting to explore, and we're also starting to kind of explore like the testing aspect of it because we do love the testing, but it's not easy that I've seen.
I mean, technically, you could mock all your reducers are very testable, right? You could send them a state and then inspect the output.
Except for your React views, like everything else actually should be pretty easy because it's all pure functions, right? So it's like if I give it this input, it should go all the way through the chain. It should get this out. I just haven't done it yet, so I don't know.
Do you guys test your routing?
I haven't. Right now we don't do anything, but normally I would. I think the path I went down last time was I was mocking out my router so that I could make progress. But
it's kind of bad, right? We were watching that one hack summit, and he's like, "Oh, I just make everything so small I don't need to test anything." I just compose them all. I'm like, "Oh, sorry."
I remember almost table flipping during that. I don't know. Does anyone else have experience with testing in React? So maybe that should be a talk at one of these 600S ones.
Well, we were doing the initial talk, and what me and Nick were me and Nick were talking about it. And it was funny because I think the testing story has changed in the 4 months that it's been.
Rendering was introduced.
Yeah, it's already a lot better.
Like the test utils, like those that API still live, which I still don't like the scary stuff. I still understand.
when testing, that's where having pure React components is really good.
Really nice.
Because if you have any kind of data fetching going on inside of your React component, it's very, very nasty. You have to mock up a million different things.
Right.
But again, if you have your entire UI state in one object at the top of your UI hierarchy, then all you have to do is plug that in, and you know what it should look like.
Right. But you're just moving that testing complexity. You're actually say your reducer has to fire an AJAX call to modify the state. You're just moving that complexity. Now you have to mock and spy AJAX in.
Well, not exactly. That's one of the things the Flux model provides, especially Redux.
Right.
Because you don't have to fire off that AJAX call. Because what happens when you do this with the Flux architecture, let's say you want to like a post.
Right.
Okay. When you click on that button, you tie in the button click, the on-click event, with your action, which is like post. That action then, if it's just like the to-do MVC, it calls a store directly. If you're talking to a server, that action is going to start by firing an update to the store directly to update your local state optimistically. Then the action is what's doing the AJAX call.
Right.
when it gets that data back from the server, it'll call the store again to update. But if you're doing testing, all you have to do is shut off the API requests. The store gets the appropriate response.
So you say your action guys on page, how do you make action creators will do that?
In a Facebook model, they create action creators. Redux does use action creators. But essentially, that's that third component. The store never modifies data. It only responds to modifications.
There is, yeah.
So I think Redux, they call them actions, but I think they are actually action creators. Like you're basically like you're doing some stuff and then firing off an action. So the way we do it is like you do some stuff, including that Ajax request. And then fire off the action.
So this is silly, but you guys probably already know about it, but I've never really read an in-depth article about middleware, and the Redux docs have an entire section, the 1.0 docs have a section about middleware. It's insanely good. You guys should all go read it. And it just talks about middleware at a general level, like how to implement middleware. And at the end of the article, you're like, holy shit, like now I know how Express does their middleware implementation in Java. And it's super cool because it uses all the things like currying and things like that, functional programming concepts. It's like nuts.
Yeah, I would not only just the docs, but like I this weekend just started reading the PRs because I'm like, this guy is like genius level smart. The people who are contributing are also genius level smart. And I'm like, all right, maybe if I read this like enough times, I'll understand a percentage of it.
Right.
And then one day, you can be like them.
Right.
So, I don't know. It's there's a lot of good concepts that they have in the PRs and in the code that I would recommend checking out. I mean, that whole thing we were talking about earlier with ES6 currying, like there's a really cool way to do currying in ES6. Came just from looking at the source code of Redux. So it's pretty
awesome. Thanks, man. All right.